Hi everyone, my name is Cameron Manfredi again, and this presentation I'm going to talk about SDLC models and a hybrid model that I created to meet the requirements for this project. So to give you a quick introduction, when an organization or company begins making changes and evaluating different systems they might have in place, the SDLC, the Systems Development Lifecycle, can become an important factor when beginning the process. The SDLC is a model used in project management and helps describe the stages that are involved in a system development project. Excuse me. There are multiple methods that were created for SDLC to help assist in the process. Some models work better in larger projects, some models work better in smaller projects. The methodology consists of basic steps, which include evaluating the current system in place, identifying new requirements, designing a proposal, developing a new system or developing the system to be in place, or finally implementing the system and testing it. There are many models that I'm going to talk about, which can include spiral model, agile model, waterfall model, rapid prototyping, and object-oriented model. I'll give you a brief history, starting with the spiral model. The first model, or the spiral model, was introduced by Barry Boehm in 1988 in a paper he was writing. This spiral model explains why iteration matters. This model combines features of the prototyping model and the waterfall model, which I'll talk about later on. This model is also used for larger projects. It could be used for small projects as well, depending on the type of project you have to complete. There are 4 phases in the spiral model. The four phases are identification, design, construction, and risk analysis. The first phase, which is identification, begins with gathering all the requirements. These requirements can include system requirements, subsystem requirements, and unit requirements. In this phase, it's important to understand the system requirements themselves. This can begin by using constant communication between the customer and the system analysis that's assigned for the project. The next phase is the design phase. This phase begins with the conceptual design, the architectural design, the physical product design, and then finally the final design itself. The third phase, the construction phase, this phase begins with producing the actual product. Once the product is thought of and the design is being developed, a POC, a proof of concept, is developed to begin receiving feedback from the customer. In the final phase, this phase begins by identifying, estimating, and monitoring the feasibility and management risks that could apply to the project itself. These risks can also include schedule slippage and going over the budget limit. Once the final product is tested, during the first iteration, the customer then evaluates the software and provides the feedback. Some typical uses of the spiral model can include when a company has a budget restriction for medium, small, high-risk projects, and if the customer is unsure of some requirements. The next model is the agile model. The agile model was developed in 2001 by a group of people. They came together and created what's called the Agile Manifesto. The Agile Manifesto is a declaration of 4 pivotal values and 12 principles to guide people through system and software development. Those 4 important values that they talked about in the manifesto are individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and then finally responding to change following a plan. There were 12 principles as well that were included in the manifesto. I'll touch briefly on just a few of them. Some of them include satisfying customers through early delivery of work, recognizing the best work that comes from self-organizing teams, providing motivated individuals with support and the environment needed to get the job done, and welcoming change requirements. The goal of the Agile model is to adapt to change and deliver working products as quickly as possible. The Agile model also includes like a process flow. Their process flow, kind of like the phases from the spiral model, their process flow includes concept, inception, iteration/construction, release, production, and retirement. Concept means is when the projects are prioritized. The next one is inception, where the team members are identified, the funding requirements, everything like that is discussed before it's actually begun. The iteration process is when the development team begins working to deliver a working software based on the requirements that they were given by the customer, and then also feedback that they're given as well. The next is release, which includes quality assurance, internal and external training, and final release out into the production. The production phase is ongoing support of the software, so constantly updating, fixing any bugs. If there's any other problems that need to be updated or changed, that goes through this process. And finally is retirement, which is the end-of-life activities, which includes migration. The Agile model breaks products into small incremental builds. These builds then are provided in what's called iterations. Each of these iterations involves cross-functional teams working simultaneously on multiple areas, including planning, requirement analysis, design, coding, and testing itself. The next model is the waterfall model. The waterfall model was invented by Winston W. Royce around 1970. This model was the first process model that was really introduced for the SDLC. It's also known as the linear sequential life cycle model. When this model is broken down, each phase must be completed before moving on to the next phase, which seems typical in a system. You want to make sure the first product is finished before moving on to the next one. It's a step-by-step process. There's no overlapping in each phase. Some of the stages and phases of the waterfall model include requirement gathering and analysis, the system design phase, implementation, integration and testing, development of system, and maintenance. Requirement gathering and analysis. This is when, in this phase, all the possible requirements of that system that are needed are documented, noted in this phase particular, and then it's documented also for further use. The system design, the next phase, the requirements and specifications that are stated in the first phase are then studied, and a system design is then prepared. This system helps specify hardware and software requirements to assist in defining the whole system structure itself. The next one is implementation. After receiving inputs from the phases before, the system is developed into small programs, which are called units. These units are then integrated into the next phase. Each unit is developed and then tested for functionality. The integration and testing phase. All of the units that are developed in the previous phase, which is the implementation phase, are then integrated into a system after testing each unit. The system is then tested for any failures or functional issues. The deployment of system, once obviously the testing is completed and working properly, the product is then deployed to a working environment or released out to the market. Finally is maintenance. There may be issues that can occur during the release or during the working environment. To solve these issues, patches are released. New and better versions may also be released as well to improve the product. Maintenance is done to deliver these changes back to the working environment after they're finished with it. The next model is the Rapid Application Development Model, or the RAD model. The RAD model consists of prototyping and iterative development that does not involve any specific planning. This model focuses on gathering requirements from the customer through focus groups, early testing of prototypes by the customer, reuse of existing components, and continuous integration. This model consists of 5 different phases. Those 5 phases are business modeling, data modeling, process modeling, application generation, and then testing and turnover. The business modeling phase, this is designed for how the information is distributed between various business channels. A business analysis is performed to find vital information for the business, how it can be obtained, how and when that information is processed, and then the factors that make the flow of the information successful. The information gathered in the previous phase, the next phase is the data modeling. In this phase, the information that was gathered in the previous phase is now reviewed and analyzed for data objects that will be important for business. The features of all these data objects and sets are identified and defined properly. The next one is the process modeling. The data sets that were identified in the previous phase are now converted to establish the business information flow needed to achieve specific objectives. The process model for any changes or enhancements are defined in this phase. Application generation. The actual system is then built and the coding is completed by using automation tools to convert process and data models into prototypes. And then finally is the testing and turnover. The testing time is reduced in this model as the prototypes are tested during every iteration. Since most of the programming components have been tested, it then reduces the risk of any major issues. And finally is the object-oriented analysis and design model. This model visualizes things in an application by using models organized around objects. Any software development approach goes through 3 stages, which is the analysis stage, the design stage, and the implementation stage. To highlight on those stages a little bit more, the first stage, which is object-oriented analysis, this phase the problems are devised, user requirements are identified, and a model is built based upon real-world objects. The analysis produces models on how the system should function and how it should be developed. The next one, which would be object-oriented design, this phase kind of breaks down into 2 main stages, which is like a system design phase and object design phase. In the system design phase, the architecture of the system is created itself. The system is composed of a hierarchy of interacting objects grouped into classes. The emphasis is on the objects comprising the system rather than processes in the system. And the second one is the object design. In this phase, a design model is developed based on both the models developed in the system analysis phase and also the system design and architectural design from the previous phase. The design system decides if new classes are to be created, if any existing classes can be used in original form, or if new classes should be inherited from existing classes. The final phase is the object-oriented implementation and testing phase. In this stage, the design model developed in the object design phase is translated into code. The databases are created, and the requirements are determined. Once the code is working, it is tested using techniques that specialize in identifying and removing errors in the code. So part of our project was to talk about all the advantages that each of these models can bring and make sure we can create a hybrid model that doesn't use any of the disadvantages that these models could use. Some advantages of each model, I'll break it down, starting with the spiral model. Some advantages are the changing requirements can be accommodated. They allow use of prototypes. Requirements can be captured more accurately. Users can see the system early, which is good for feedback and further recommendation down the road. And development can be divided into smaller parts. As for the agile model, some advantages of the agile are a realistic approach to software development. It promotes teamwork and cross-training. Functionality can be developed rapidly. Resource requirements are bare minimum. It's suitable for changing requirements, it's easy to manage, and it's flexible for developers. The waterfall advantages would be it's simple and easy to understand and use. It's easy to manage. Phases are processed and completed one at a time. There's clearly defined stages, and it's also easy to arrange certain tasks for certain team members. The rapid application, the RAD model. Changing requirements can be accommodated. Progress can be measured. You can reduce development time. There's quick initial reviews, which encourages customer feedback. Finally is the object-oriented analysis and design advantages. This model, it's easy to understand, easy to maintain, provides reusability, and reduces development time and cost. Next, I want to speak a little bit about project management. It wasn't a big part of this paper, but I think project management falls under the category for almost every system that might be created. When developing a system, using project management process helps break down the project into 4 different phases. These 4 phases are to initiate the project, plan the project, execute the project, and then finally close the project. In the first phase, the project manager performs several activities to assess the size and the complexity of the project itself. They also establish procedures to support their activities. Some of the steps in project initiation, which can include establish the project initiation team, build a relationship with the customer, create a project initiation plan, management procedures, environment and workbooks, and then finally developing the project charter itself. In the next phase, the project planning can include steps such as describing the project scope and the feasibility, dividing the project into tasks, creating a resource plan, developing a plan, and then finally determining procedures and budgets down the road. The third phase consists of executing the project itself. It can include steps such as executing baseline project plans, monitoring the project progress, managing changes, and then communication of the project status with other team members and with the customer themselves. The final stage is closing down the project. Includes steps such as conducting post-project reviews and then also closing out the customer contract. Project management coincides with a lot of different models in different ways. Some of the steps that occur in project management occur in some of the benefits in a lot of these models. For example, determining a budget and project plans are important because both models have to proceed through these steps to establish their system development. Project management brings a unique focused shaped by the goals and resources of each project. The rapid growth of project management provides the value of that focus. So now I want to talk a little bit about the hybrid model I created. So after analyzing all of these different SDLC models, I created a hybrid model that implements different phases and aspects from each model and combines them into one hybrid model. I broke the hybrid model down into 6 phases. Those 6 phases are requirements and specifications, risk identification, planning, design, testing and feedback, and finally maintenance. Kind of touched basically on this briefly, but go over them. For the first phase, for requirements and specifications, I would say in this phase all the possible requirements are gathered for the project and system. Find out what the customer needs, what specific that they need, whether it is a requirement or specification, and make sure you document those so you have them for future use. The next stage would be risk identification. In this phase, we begin identifying, estimating, and monitoring the management risk and the feasibility risk. Like I said before, some of these risks can include going over a budget that may be set by the customer, falling behind if you're on a strict schedule. So those are important to make sure you identify risks that can occur while creating this project and finishing the project. The next phase would be planning. In this phase, after we have already gathered the requirements, specifications in the earlier phase, even in the risk too as well, we would then provide a plan to break down how this job will be completed and what our goal is, what our structure is to complete this project. Next would be the design phase. After creating a plan for the system or the job required, we then create the design. This will come from previous phases, which include hardware and software specifications. The next phase would be testing and feedback. All of the designs that are developed in the previous phase are then integrated into a system after testing each unit. The system is then tested for any failures or functional issues. Finally, after the initial testing, feedback is provided by the customer, team members, and any others who may be involved so we can make sure the product is working properly. The final phase would be the maintenance phase. In this final phase, after receiving that feedback and testing the results, we would implement changes while maintaining a functional and working system. I'm going to just switch over real quick to show you a brief picture of the model I created. Give me 1 second. So as you can see there's the requirement specifications, the risk identification, the planning, the design, the testing and feedback, and finally the maintenance phase. So, pretty much in conclusion for this paper, when working for an organization, or even if you own an organization, you're going to have to adapt to changes that can happen in the community and in a working environment. In order to stay ahead of this, you need to be able to adapt a system development method to your situation. There are multiple different methods you can use in your system and your software's development lifecycle phase. For example, the Spiral model has 4 different phases. The Agile model has 4 important values. A lot of these different phases and values, their main goal is to complete the same thing. Make sure you get the product divided in properly. You assess the risk possibilities that could come with it. Design a proper system in place. Complete the instruction, and then finally give testing and feedback, and then continue maintenance. The waterfall model also has certain phases. They must be completed, of course, to move on to the next phase, which I think is very important, because instead of trying to jump around through the project to complete certain parts, and could cause you to step back or could cause you to miss something, I think it's important to go step by step, make sure everything's complete in each phase before moving on to the next one. The RAD model, it's a methodology that favors rapid prototyping. I think that's great because you can kind of create a prototype early for the customer so they can see what they're getting into and what their product's going to be looking like. The object-oriented analysis and design model. This model visualizes things in an application by using models organized around objects. These models can be applied to real-life situations and events to help their systems evolve. Either way, I would say your company is well cared for to adapt to changing in the world today, as long as you follow certain models. SDLC models are great to follow to make sure you are constantly updating and you have a proper system in place. So that's my hybrid SDLC model type. For the rest of this video, I'm going to talk a little bit about our final project. The goal of our final project was to pretty much create a virtual lab for Youngstown State University. We were split up into different groups, and a lot of this virtual lab's got a lot of different parts that's broken down into. There's a database section to it, there's a security section to it, social media section to it. There's a lot of different sections that this project can break down into that are very important for this project itself. I'm currently in the security group and inside the social media group. To touch briefly on what we've done so far, for social media, most of the team members and I, we've gone through and we created a Gmail account, so we have an email set up down the road for we can log in with the same account and create different accounts through social media using the same sign-in login. We also created a Facebook page. Facebook's one of the most popular social medias out there, so it's important to be able to connect with people through social media besides just email. So we have a Facebook page out there, and we're also creating a Facebook group and another page inside of our Facebook account. So that way, not only do we have a Facebook account, but we can also put some ads out there or throw some documents on a Facebook page so people can see them as well. And then in the meantime, get a group together so people can start looking into the virtual lab project that we're working on for YSU, and hopefully see, or even provide any feedback that they might have. Another phase we created was Reddit. To be honest, I'm not too familiar with Reddit. I've never really used it before, but from what I've researched and from what I've found out, it's a great way to communicate with other people about, honestly, you can communicate about anything, but it's nice to communicate about certain topics that can lead to our virtual lab itself, whether it's technology or it's virtualization or security, anything like that. A lot of that can tie into our project. So receiving feedback or receiving information from other people that might be working on the same thing can be very helpful for us. We didn't do too much more for the social media group besides that, using actual social media itself. We could have created a Twitter page, we could have created an Instagram page, but again, I think just our main goal is to get the word out there. If that's just using Facebook for now. I know there's a team that's developing a website for our project as well. That's going to be great because then people can visit the website that we would have created for a virtual lab, find out more information about our virtual lab, what it can do, what's going to be required if you want to use the virtual lab, and if the virtual lab is even going to be obviously implemented down the road at YSU. So we're hoping that's going to be a big step down the road for this project. As for the other group I'm in, which is the security group, so a lot of us worked. This is a little bit harder part of the project for us to work on because security is a very important thing today in the technology world. You need to make sure your equipment's secure, your systems are secure, make sure no one's hacking or anything like that. So it's important to have a strong security plan in place. So to briefly just quickly touch on some of the things we came up with. So for our security plan, we talked a little bit about electronic access, and we looked into Tyco Integrated Security. Tyco Integrated Security. Tyco uses a range of electronic access control devices and locks and systems with management tools to help you control these devices, locks, and systems. This is going to be important because of the fact that Tyco not only offers complete support in the layout, installation, and assessment of the systems, but beyond the security portion, the access control technology delivers valuable business intelligence and allowing the person in charge or the owner of the company to know who's entering and leaving the facility, what time they came in, came out, and how long they were there for. So I think that's very important for a virtual lab down the road. Same goes for physical location access. Tyco integrated security, key card access to certain rooms, like the equipment room is a key point that we would probably want to stress. The alarm must be activated, obviously, when no one's in the building. And then there should be only like a handful of people that should have access to certain equipment rooms, certain server rooms, certain lab rooms as well. We talked a little bit about physical authentication. This is where we looked into ADT installation. One card system will be installed for the virtual lab so that only people with the access cards have access to the lab itself. So I think this is important because it's one of the best ways to improve the security for your site, and it restricts the amount of people that can enter the virtual lab. One of the main parts we kind of wanted to focus on was electronic authentication. So digital certificates may be used for authentication to ensure that the registered user is in control of the authentication tokens. We kind of created 3 permissions: a level 1 permission, level 2 permission, level 3. Level 1 pretty much is you have access to the lab, you can print, and you have permission to view the lab resources. Level 2 is access to the testing and coding room, permission to create lab resources, you can update policies, and then everything that level 1 can do. And then finally would be level 3, which is everything level 1 and 2 can do, plus more, which would be access to the server room, access to the financial data and personal files, permission to edit and delete files, access to physical resources. You can add and remove users for the virtual lab, and then request equipment or resources. We touched a lot about data recovery, disaster recovery, physical protection. So I think what we have in place for our project for the security side of it, I think we're at a really good start. Obviously, one of the other things we kind of wanted to stress was any code that we might be creating for security purposes. If we need to send that through or anything like that, we need to make sure it's encrypted before sending it through. That would be an important factor because we want to avoid malicious attacks and also avoid being flagged by the email server that we're sending it through. So I know that's something we're constantly working on right now. I'm trying to touch that up a little bit and finish more. So those are the 2 groups that I were in, at least. I know the rest of the groups, we've met almost every day we had during class for lab time to try to see where everyone was at with the project. Sounds like we should be to the point where we're just about finished now. And I think our main goal now is just to kind of let our project management team take over the rest and finally put everything else together that we provided for them. I know we have a lot of people on the project management team that know what they're doing. They found some templates that are going to make it look really interesting and make this product look very legit and hopefully successful down the road as well. So to kind of touch base, the SDLC model that I talked about, I created the hybrid. I think that's important to be able to use different phases that maybe each model uses, along with making sure the advantages of each of those models work together to make sure you have a complete and working system or software project down the road. And as for the project, like I said, we're finishing touches on it now. Hopefully we've been able to complete what we were required to do, and hopefully this down the road gets further implemented, whether it's someone gets this sent in, if Professor Hughes himself makes changes and adjustments to it and actually submits it to maybe Youngstown State or something, see if we can actually get this implemented, because I believe virtual lab could be something very useful for the school later down the road. I know with graduating this weekend, I would have loved to have been able to use a virtual lab at YSU, but hopefully for kids in the near future, that could become a realistic thing. So thank you very much for your time, and have a great Christmas. Bye-bye.